Hello, welcome to my lesson. The topic of today is water and hydrogen, and my name is Masika Michael. I teach chemistry and biology at Nasokol Girls in West Pokot. To find me on YouTube, just search the word Chemistry Revision Master and then subscribe to enjoy my chemistry videos. So I'm going to take you through the topic of water and hydrogen using the question and answer approach. To begin with, I'm going to take you through the laboratory preparation of hydrogen gas using this question. The diagram below represents a setup for laboratory preparation of hydrogen. And this is the diagram. You're looking at the diagram. There is dilute hydrochloric acid in a dropping funnel. There is zinc, delivery tube, then there is hydrogen. Finally, there is hydrogen here. The first question is write an equation for reaction that occurs in the conical flask. So this is the conical flask. There is a zinc metal and there is dilute hydrochloric acid. So the reaction involves zinc solid, Zn solid, reacting with a HCl, that is hydrochloric acid, to form zinc chloride, ZnCl2, and hydrogen gas. Remember, in this reaction, zinc metal is above hydrogen in the reactivity series. So when added to hydrochloric acid, it's going to displace hydrogen ions from hydrochloric acid, and now hydrogen ions coming out of the solution in the form of hydrogen gas, then zinc going into the solution, forming zinc chloride solution. Question B. State and explain one observation made in the conical flask. And the observation is production of effervescence. Effervescence, the other name for effervescence is bubbles. Instead of using effervescence, you can use bubbles or fizzing. That is the observation. And the explanation is due to production of hydrogen gas. Then question C. Name the method of gas collection used and give a reason why it is used. Now, looking at this experiment, zinc is being reacted with dilute hydrochloric acid and hydrogen gas is being produced. It's passing through this delivery tube all the way to this other end and it's being collected here. But when you look, it's being collected over this water. So the method of collection in which a gas is collected over water is called the over water method. And the reason is because hydrogen is insoluble in water. Question D. What is the suitable drying agent for hydrogen? So hydrogen is a neutral gas and it can be dried by use of any drying agent. One is concentrated sulfuric 6 acid. You can also use calcium oxide, and indeed you can also use anhydrous calcium chloride. And on the same setup, you can be asked to give a reason why zinc is the preferred metal for this experiment. When preparing hydrogen, zinc is preferred to be reacted with dilute hydrochloric acid over other metals. The reason is because zinc reacts moderately with dilute acids. But you can also be asked, apart from the main reagents, name the substance added to the reaction mixture and state its role. In the reaction mixture is zinc and dilute hydrochloric acid. The substance added is copper 2 sulfate crystals, and their role is to speed up the reaction. Question G. Give a reason why sodium and potassium metals cannot be used to prepare hydrogen gas. And when you use potassium or sodium, they are very highly reactive metals, so they react explosively with dilute acids, and that one can cause an accident. Then H. Explain why the following reactions will produce a negligible amount of hydrogen gas. That is the reaction between lead and dilute hydrochloric acid. Lead cannot be used to prepare a reasonable amount of hydrogen gas when reacted with dilute hydrochloric acid. The reason is because The reaction between lead and dilute hydrochloric acid starts, then eventually stops due to formation of an insoluble layer of lead 2 chloride, which coats lead metal, preventing further reaction. The equation for the reaction is lead solid plus 2 moles of HCl, that is dilute hydrochloric acid, to form lead 2 chloride solid and hydrogen gas. So this lead 2 chloride solid form, you can see it's a solid, so it is insoluble, and as the reaction proceeds, it's going to coat lead metal and the reaction will stop. Roman 2, reaction between lead metal and dilute sulfuric 6 acid will also produce a negligible amount of hydrogen gas. The reason is because when lead metal is reacted with dilute sulfuric 6 acid, there will be formation of lead 2 sulfate, and lead 2 sulfate is insoluble, so it will coat lead metal and prevent further reaction. That's why we shall say that the reaction starts, then eventually stops due to formation of an insoluble layer of lead 2 sulfate, which will coat the lead metal, preventing further reaction. And the equation for the reaction is lead solid plus H2SO4, that is dilute sulfuric 6 acid, to form lead sulfate solid and hydrogen gas. And another question is that also you are also supposed to explain why the following reactions will produce a negligible amount of hydrogen gas. That is the reaction between barium metal and dilute sulfuric 6 acid. You say that the reaction starts, then eventually stops due to formation of an insoluble layer of barium sulfate, which coats the barium metal, preventing further reaction. And the equation for the reaction is barium solid reacting with sulfuric 6 acid, that is H2SO4, to form barium sulfate solid, since it is insoluble, and hydrogen gas. Then you can be asked the reaction between zinc metal and dilute nitric 5 acid. Why is it that the reaction between zinc metal and dilute nitric 5 acid will not produce a reasonable amount of hydrogen gas? And the reason is because the hydrogen formed when zinc is reacted with dilute nitric 5 acid is immediately oxidized to water, since nitric 5 acid is a strong oxidizing agent. And the equation for the reaction is zinc metal plus nitric 5 acid to form zinc nitrate, water, and nitrogen 4 oxide. Then you can be asked about the physical properties of hydrogen gas. State 3 physical properties of hydrogen gas. 1. It is colorless, odorless. Hydrogen is insoluble in water, and it is less dense than air. Then you can also be asked, apart from the over water method, name 2 other methods that can be used to collect hydrogen gas. One method, you can use upward delivery method, since hydrogen is less dense than air. Then you can use a syringe. Remember, a syringe can be used to collect any type of gas. Then state 3 uses of hydrogen. Hydrogen has a variety of uses. 1, it is used in hot air balloons because it is light. 2, it is used in the manufacture of ammonia in the Haber process. And number 3, hydrogen is a raw material in the large-scale manufacture of hydrochloric acid. And hydrogen is also used in hardening of oils to form fats. And this process is called hydrogenation. Then you can be asked about the sources of hydrogen. You need to know the sources of hydrogen. You can get hydrogen from cracking of alkanes, and also from electrolysis of brine. Brine is a concentrated solution of sodium chloride. Then another thing is why is helium preferred over hydrogen for use in hot air balloons? The reason is because helium is inert, but hydrogen is reactive, despite the fact that it's lighter than helium. Then explain why iron is not used in the preparation of hydrogen gas. The reason is because iron contains sulfur impurities that results in formation of the false smelling foul-smelling hydrogen sulfide gas in addition to hydrogen. Then, can you describe the test for hydrogen gas? Yes. To describe that, immerse a burning splint. Immerse a burning splint, not a burning plant. Immerse a burning splint in a gas suspected to be hydrogen. If the gas extinguishes the burning splint with a pop sound, then the gas is hydrogen. Then I will also use this question 2. This question will help you understand the properties of hydrogen gas, particularly the chemical properties. And one of them is being demonstrated here. You can see hydrogen is being passed over copper 2 oxide here, and there is a combustion tube, and there is an anhydrous cobalt 2 chloride that has been placed here. And this, finally, there is a gas that is being burned at the jet. And question A, you are being asked to identify one condition missing in the setup. Now the condition is that on this copper 2 oxide we are supposed to have heat. So the missing condition is heat on copper 2 oxide. Heat must be there for copper 2 oxide to react with hydrogen. Then state one mistake made in the setup. Looking at this setup, you can see everything is set right, but there is heat on anhydrous cobalt 2 chloride. That one is a mistake. Anhydrous copper 2 chloride is not supposed to be heated. So the mistake is heating of anhydrous cobalt 2 chloride. Question C, explain why it is necessary to pass hydrogen through the tube before lighting at the jet. So hydrogen should be passed through the combustion tube before lighting this jet here, is to expel air, since a mixture of hydrogen and air will explode when ignited. Then question D, state and explain the observation made in the combustion tube if the missing condition is provided and the mistake is corrected. So there are a number of observations that are going to be made. Allow me to take you back to the setup. Hydrogen is being passed over a heated copper 2 oxide. Looking at the reactivity series, including hydrogen is above copper in the reactivity series. So hydrogen is going to take oxygen from copper 2 oxide, and now hydrogen will be oxidized to water, and copper 2 oxide will be reduced to copper metal, which is brown. And the water formed will therefore form a colorless liquid on the polar parts of the combustion tube, and also it will cause anhydrous cobalt 2 chloride to become hydrated. So the observations that will be made in the combustion tube first is that the copper 2 oxide changes from black to brown since it is reduced by hydrogen to copper metal. 2. A colorless liquid is formed on the polar parts of the combustion tube since hydrogen is oxidized by copper 2 oxide to water. 3. The colorless liquid turns anhydrous cobalt 2 chloride from blue to pink, showing that the liquid that is formed is water, which causes anhydrous cobalt 2 chloride to become hydrated. Question E, you have been asked to write an equation for the reaction taking place in the combustion tube. So in the combustion tube, copper 2 oxide is reacting with hydrogen gas to form copper metal and water. Now, a Form 1 can be asked to write a word equation, but a Form 2, 3, and 4 should be able to write a chemical equation. So the chemical equation involves copper 2 oxide, which is CuO. Copper 2 oxide is black, reacting with hydrogen H2 gas to form a copper metal, which is brown, and water liquid. So from this you can see that hydrogen has taken oxygen from copper 2 oxide to become water, and copper 2 oxide now has been reduced to copper metal. Question F, which property of hydrogen is being demonstrated in this experiment? And the property is the reducing property, because hydrogen is a reducing agent. It is removing oxygen from copper 2 oxide, and that one is removal of oxygen is reduction. So that shows that hydrogen is a reducing agent. G Roman 1, why is it necessary to burn excess hydrogen at the jet? Remember, if I take you back to the setup, at the jet, excess hydrogen is being burned here. Why should it be burned? And the reason is to prevent it from escaping into air, since there might be an explosion when it burns mixed with air. Then what is the color of flame produced at the jet? What is the color of flame produced when hydrogen burns? The flame is blue. That is because hydrogen burns with a blue flame. Then write an equation for burning of pure hydrogen. The equation is H2 when hydrogen burns in air. Remember, burning of a substance is just a substance combining with oxygen with production of heat. So hydrogen gas will combine with oxygen to form water. 2 moles of hydrogen plus 1 mole of oxygen gas to form 2 moles of water liquid. That is the equation for the reaction of burning of hydrogen at the jet. Then you can be asked to describe an experiment that can be used, that can be carried out to show that water is an oxide of hydrogen. So to describe this, the first thing, pass hydrogen through a tube containing anhydrous calcium chloride to dry it. Then ignite the pure hydrogen at the jet. Cool the products of burned hydrogen using ice cold water to form a liquid. Test the resulting liquid using anhydrous copper 2 sulfate. The liquid turns anhydrous copper 2 sulfate from white to blue, showing that water is formed when hydrogen burns in air. That water is formed when hydrogen burns in air. Thank you very much for watching my video. Don't forget to subscribe to get the other areas of content that I post regularly.